Hello everyone, myself Kalpana Choudhari, Department of Chemistry, RBNB College, Srirampur. Today we are going to see the concept of intermolecular forces of attraction from the topic states of matter. Now let us see first what is intermolecular forces. These intermolecular forces are the forces of attraction as well as forces of repulsion which are present between atoms, ions or molecules. Now here one thing is important, there are generally two types of forces, intermolecular forces, and intramolecular forces. Intermolecular forces of attraction and intramolecular forces of attraction. Although we are saying that these are the forces of attraction, but sometimes repulsive forces are also exist between atoms, ions or molecules. Now here when there is force of attraction or repulsion between one molecule and another molecule, that means that force of attraction or repulsion that exists between two different molecules, then such type of forces are referred as intermolecular forces of attraction. And intramolecular forces of attraction, these are the forces of attraction which exist within one molecule. And so here the strength of forces, if we compare, then generally intramolecular forces of attractions are stronger than intermolecular forces of attraction. Now let us see here, we have to see in detail what is meant by intermolecular forces of attraction and their different types. Now let us discuss about intermolecular forces. Now here there are total 5 types of interactions or exist between atoms, ions or molecules. Now that forces of attraction or repulsions are nothing but intermolecular forces, and how that attractions and repulsions are there, that is shown by different types of intermolecular forces. Total 5 types are there. Now let us see one by one which are that types. Dipole-Dipole interactions. Dipole-Dipole interactions. Second type that we have to see, ion dipole interactions. Third type that we have to see, dipole induced dipole interactions. Fourth type that we have to see, that is hydrogen bonding. And last one, London dispersion forces. Now here within two molecules or within that molecules, such type of interactions are seen. Generally that intermolecular forces of attraction, that means these interactions are present between two different atoms, two different ions or two different molecules. Now depending upon the type or nature of that atom or molecule, such type of interactions are seen. Now let us see one by one these interactions with example. Let us see our first type, dipole-dipole interactions. Now dipole-dipole interactions means what that we have to see here, but before that we should know what is mean by dipole. What is mean by dipole and how that dipole-dipole interactions are existing in the molecules. Now here generally that covalent molecules, covalent, that means here when covalent bond present between whatever that atoms in a molecule, such type of molecules are said to be dipoles, or such type of molecules are said to be polar molecules. Now here what happens, there are interactions takes place. The interaction takes place between positive end of one polar molecule. Interactions takes place between positive end of one polar molecule and negative end of another polar molecule. The interactions which takes place between positive end of one polar molecule and negative end of another polar molecule. Such type of interactions are called as dipole-dipole interactions. Now here what is mean by dipole? Any covalent molecule in which that covalent bond is present. Now we know that what is that covalent bond? When there is share in an electron pair takes place between two atoms. That means the electronegativity difference between two atoms in which that covalent bond exists. Such type of molecules are said to be dipole molecules, and also such type of molecules are referred as polar molecules because due to electronegativity difference, dipole formation takes place on the atoms of that molecule. Now how that polarity exists, that we'll see here. For example, if we consider example of HCl molecule. Here in case of HCl, we know that this hydrogen atom is positively charged atom, chlorine that is electronegative atom, and so electronegativity difference between hydrogen and chlorine that is high. And so here what happens, whatever there is share in an electron pair takes place between this hydrogen and chlorine to form bond between hydrogen atom and chlorine atom. This share in an electron pair that is attracted more towards chlorine atom because that chlorine atom is more electronegative than hydrogen. And so here what happens, due to pulling of this electron towards chlorine atom, here partial charge formation takes place on this chlorine atom, and that is denoted by this delta, Greek letter delta, and negative charge formation, so negative sign is indicated. And here hydrogen that is positively charged because here that electron density pulled more towards this chlorine atom. Electron density is pulled more towards this chlorine atom. Electrons are pulled towards chlorine atom which are shared between hydrogen and chlorine to form covalent bond. And so here positive charge formation takes place on this hydrogen atom which is said to be partial positive charge, and that is denoted by this Greek letter delta. Greek letter delta. Now here there is charge separation takes place between these two atoms in a same molecule, and so we can say that here polarity exists in this molecule due to the charge separation, and this happens due to the electronegativity difference between hydrogen and chlorine atom. Now here whatever this electron density exists within this molecule, here we can say that more electron density or more electron charged atom. Here electronegativity difference is more, electrons are pulled towards chlorine atom, and hence here electron density on this chlorine atom increases in HCl molecule, and due to that here negative charge separation takes place, that is partial negative charge, and that is denoted by this delta symbol with negative charge. Partial positive charge separation takes place on hydrogen atom denoted by plus delta sign, and hence here HCl molecule is polar in nature, and this one end is called as positive end or positive end of this molecule, or we can say that positive dipole, and this is called as negative end of this polar HCl molecule, or this is also called as negative dipole. And so here positive and negative dipole formation takes place due to the electronegativity difference between atoms in a molecule, and thus here dipole formation takes place. Now here we have to see what is that dipole-dipole interactions are there. Now here what happens here, when positive end of one molecule that is get attracted towards negative end of another molecule, then such type of interactions are called as dipole-dipole interactions, because these interactions happens between two different molecules. But here interactions happens between positive dipole of one molecule and negative dipole of another molecule. Now let us see how that interactions takes place. For example, we'll see here. For example, if we draw this structure Cl, now this HCl bond, here delta plus sign, delta negative sign. Now here when another HCl molecule comes in the vicinity of this molecule, first HCl molecule, then here negative end of this HCl molecule that is attracted towards positive end of another molecule, where that positive dipole formation is there. Now if third molecule comes in the vicinity of this molecule, then here positive end of this second molecule that is attracted towards negative end of another HCl molecule, where this negative dipole formation takes place. That means here what happens, there is interaction takes place between negative end of one molecule and positive end of another molecule, and so these interactions are called as dipole-dipole interactions. And here magnitude of these interactions that is given by magnetic moment, that is denoted by mu, and is equal to Q into R. Here strength of these interactions that is calculated by using magnetic moment, mu, that is equal to Q into R. What is this Q? That is the charge present on that particular molecule. And what is that R? That is the distance between two dipole exist within that molecule. That means we can say that R is the distance between positive dipole and negative dipole that is present within that molecule. And so here there is strength of these dipole-dipole interactions that depends upon the electronegativity difference between two atoms within the molecule, and that strengths are given by the formula mu is equal to Q into R. And unit of this dipole moment that is given by dBi. Unit of dipole moment that is given by dBi, and that is denoted by capital D. That is denoted by capital D. Now let us see the second type of interactions. These are ion dipole interactions. Ion dipole interactions. Second type of interactions that we have to see here, ion dipole interactions. Now here ion dipole interactions means what? When the interactions or attractive forces are present between an ion, which may be positive ion or which may be negative ion. That means which may be cation or anion, and these interactions happens with positive end or negative end of polar molecule or with the dipole, positive dipole or negative dipole. Such type of interactions are called as ion dipole interactions. Now let us see here, for example, when sodium chloride, that is dissolved in water, then what happens? NaCl get readily dissolved in water. That means here Na plus ion and Cl minus ion formation takes place within that aqueous solution, and whatever that water molecules are there, they are surrounding that Na plus ion, and there is interaction takes place between Na plus positive cation and negative end of water molecule, that is nothing but oxygen from water. And whatever that interactions are there, that total interactions are said to be hydration of Na plus ion, because that Na plus ion are surrounded by water molecules, and interaction takes place between positive Na plus ion and negative oxygen from water. How that interaction takes place, let us see here. Na plus ion that are present at the central position, and here interactions takes place between this negative oxygen, that means here negative dipole we can say here, because here partial negative charge formation takes place on oxygen and partial positive charge formation takes place on hydrogen atom, because within this water molecule oxygen is more electronegative than hydrogen, and so electrons are more pulled towards oxygen atom, so negative dipole. And there are interaction between this Na plus ion and negative dipole of polar molecule. Now let us see here second water molecule. In this way only that interactions happens between Na plus and second water molecule with the negative dipole. Likewise here third oxygen atom. Here partial negative charge on oxygen, partial positive charge on this hydrogen. Now here fourth water molecule. Here also the interactions takes place between this negative end of this polar molecule with this positive ion. Now here partial positive charge on hydrogen atoms. Likewise here fifth water molecule that also forms interactions with this Na plus ion. Here all these hydrogen atoms are partially positively charged atoms, and here the interaction takes place between this positive Na plus ion and negative end of all these polar molecules that are water molecule. This when happen when NaCl dissolved in water, ion separation takes place, Na plus and Cl minus ion. Then these Na plus ions are surrounded by 6 water molecules, and this is called as hydration of Na plus ion. Hydration of Na plus ion. Hydration of Na plus ion. How we can define this ion dipole interactions? These are the attractive forces which exist between ions, cations or anions with negative or positive end of polar molecules. Such type of interactions are called as ion dipole interactions. Now here strength of these interactions that depends upon size of cation and anion. Size of cation and anion. Now here what happens? Depending upon size of cation and anion, these interactions are there. When size of cation is smaller and size of anion is bigger or greater than that Na plus than that of cation, then stronger interactions happens between ion and positive or negative dipole of another polar molecule. And hence here what happens? That creates covalent nature in ionic bond. When that cation size is smaller than corresponding anion, then what happens? Although the bonds are ionic in nature, due to ion and negative or that positive interactions of that polar molecule, that covalent nature is induced in the molecule. For example, if we see LiCl molecule, lithium chloride molecule, where this lithium that carries partial positive charge and chlorine carries partial negative charge. LiCl that should be ionic in nature, because here LiCl, when that is dissolved in water, there is readily separation of Li plus and Cl minus ion takes place. So the molecule should be ionic in nature. But here what happens if we compare the size of Li plus and Cl minus ion, then it is observed that the size of Li plus cation, that is too much smaller than size of Cl minus ion. And here that whatever interactions happens between this Li plus ion and negative end of polar molecule, such type of interactions are stronger interactions due to the smaller size of that Li plus ion, and so here covalent character is induced in LiCl molecule. And so here whatever that size of cation and anion is there, depending upon that strength of interactions are observed. Now let us see here the next type of interactions, third type of interactions that we have to see here, dipole induced dipole interactions. Dipole induced dipole interactions. Now when these interactions are happening, or when these interactions are observed, now here when polar molecules comes in the vicinity of non-polar molecules, then here due to the polar molecules that polarity is induced in non-polar molecule, and such type of interactions are called as dipole induced dipole interactions. For example, if we consider when water, for example ammonia, these are polar molecules. These are polar molecules. When such type of polar molecules that comes in the vicinity of non-polar molecules, which are non-polar molecules, for example if we consider benzene, xylene, these are non-polar molecules. When these polar molecules that comes in the vicinity of non-polar molecules, then here polarity is induced in these non-polar molecules due to the polar nature of these molecules. Such type of interactions are called as dipole induced dipole interactions. Now let us see how that interactions exist. For example, here we'll see ammonia. Now here ammonia, here lone pair of electron is present on this ammonia. 3 hydrogens are bonded with this central atom nitrogen. Now here in this ammonia, nitrogen is more electronegative in nature, and so here partial negative charge exists on this nitrogen atom and partial positive charge exist on these 3 hydrogen atoms. This is negative dipole and these are positive dipoles of nitrogen atom. Now when benzene having formula C6H6 that comes in the vicinity of this ammonia molecule, then here what happens? Dipole is induced. Here carbon that is showing positive dipole, hydrogen showing negative dipole. When this nitrogen from this ammonia that forms interaction with carbon atom from benzene, and due to this polar nature of ammonia, polarity is induced in this benzene molecule. This is ammonia Which interactions? Due to the negative dipole of this nitrogen atom, polarity is induced in benzene molecule. And so here these interactions are called as dipole-induced dipole interactions. Because here that polarity is induced in non-polar molecule which is having zero dipole moment. Benzene, that is having zero dipole moment, and then also here that polarity is induced due to the polar nature of this ammonia, and hence these interactions are called as dipole-induced dipole interactions. Now let us see the next point or next interaction, fourth type that we have to see, hydrogen bonding. Hydrogen bonding. Now let us see here, there are two types of hydrogen bonding takes place, which are that intramolecular hydrogen bonding and intermolecular hydrogen bonding. Intramolecular hydrogen bonding, that is present within same molecule, and intermolecular hydrogen bonding, these are present between two different molecules. Now let us see example. For example, if we see the example of intramolecular hydrogen bonding, for example, in case of ethylene glycol having formula CH2 twice OH twice. Now here what happens, this oxygen of first hydroxyl group that shows interaction with hydrogen atom of second hydroxyl group. Such type of interactions are takes place within one molecule, because here this oxygen atom that is showing negative dipole, and this hydrogen that is showing positive dipole. These interactions between positive dipole of one atom with negative dipole of second atom, but that is present in the same molecule. Such type of hydrogen bonding is called as intramolecular hydrogen bonding. And generally intramolecular hydrogen bondings are stronger than intermolecular hydrogen bonding. Intermolecular hydrogen bonding, these are present between two different molecules. That means when negative dipole of first molecule that exert interaction between hydrogen atom of the second molecule which is partially positively charged. For example, let us see here HF molecule, where fluorine is negative in nature, so there exists a partial negative charge on fluorine atom and partial positive charge formation takes place on hydrogen atom. When this HF molecule that comes in the vicinity of second HF molecule, then there is interaction takes place between negative dipole of this fluorine atom and positive dipole of the hydrogen of the second molecule of HF. So here let us show here HF. This is second HF molecule where this hydrogen is partially positively charged and this fluorine is partially negative charged, and this interaction takes place between first negative fluorine atom of first HF molecule and positively charged hydrogen atom of the second molecule. Such a type of hydrogen bonding is called as intermolecular hydrogen bonding, and this interaction takes place between two different molecules, and such type of interactions, if we compare with intramolecular interactions, then such type of interactions are weaker than intramolecular interactions. Now here when hydrogen bonding exists between liquid molecules, then that liquid molecule shows higher boiling points, because due to the inter or intramolecular hydrogen bonding, there exists a force of attraction between atoms of different molecules or atoms of the same molecule. Then that liquids are showing higher boiling points. Now let us discuss about the last type of interactions. These are called as London dispersion forces. London dispersion forces. Let us discuss about London dispersion forces. Now London dispersion forces, these type of interactions are also referred as van der Waals forces of attractions. Van der Waals forces of attraction. But nowadays these forces of attractions are referred as London dispersion forces. Why? Because in 1930, first this London scientist, he has observed that whatever that noble gas interactions are shown, that are due to the some forces of attraction, and so these interactions between noble gases, that is explained as London dispersion forces in 1930, first by London scientist. So such type of London dispersion forces means these are the weaker forces of attraction, and generally these forces of attraction that exist in halogens. For example, in F2, Cl2, Br2, such type of interactions, London dispersion forces of attraction that exist between halogen molecules, and also such type of interactions are observed in noble gases. For example, helium, neon, argon, etc. Noble gases are showing London dispersion forces, which are weaker forces of attraction. So we'll stop here. Thank you.